So there's a lot of talk right now that instead of prompting your agents, you should be writing loops or defining graphs. And the thing that makes me think a lot is that every time I see these things, I start asking myself, is this just a different way for these different companies to get us spending more tokens, get us hooked and addicted to it? Or are these real concepts that we should actually use and understand? I'll give you my answer upfront. They're real. They're not new. And to be honest, you probably are doing certain parts of it without even you knowing it. But having the name changes how well you do it. But naming these concepts actually help you understand it deeper to change how well you do it. I know this just because a few weeks ago, I lost most of my day not knowing it properly. So let me start here. I run a software product and we have this leveling system in my AI native learning portal. It's called Sigmo.dev. It's a platform that I'm building now and maintaining now for my students at Sigma School. It's a pretty straightforward feature. XP goes up, you hit a threshold and you level up, okay? And I did what I always do, which is that I will describe it properly. I will give it a context and I will then set a goal and let the agent run. I came back later and it said that it was done. I tested it, it looks good, right? Except it quietly broke another feature that I had, which is on streaks. It broke my streak logic on the way through. And I didn't catch that for 2 or 3 days. Now, my first thought was that the model wasn't good enough for this, but that wasn't it. The problem was that I told it what to build, but I never properly defined what done meant. And those are completely different things. And that gap is where I think most people are losing time right now. Because think about what a normal prompt actually is. A normal prompt works this way. You write something, you ask for something, and it does it once, it hands it back to you. You read it and you review it and you decide if it's good, right? You are actually QCing and quality checking every single round. A loop though is when you move that job to an agent, you tell it the task, but you also give it the condition it has to pass, and then it does the work and checks itself against that condition. Now, if it fails, if the condition fails, it goes again and again and again and again, like a loop until it passes, then it stops. So really there are 3 steps here. Number 1 will be the start criteria, which usually will be something like a schedule, like giving it a rule. When should you start running this loop? How frequent should you run this loop? Or it could just be you kicking off this prompt. Okay. Number 2 is the task itself. What do you want it to do? And number 3 is the success criteria, the acceptance criteria. How do you define that the goal is achieved? And until the criteria is met, it doesn't stop work. And that's a loop. And that's why people get caught in things like the infinite loop, where there is no end criteria defined. And to be honest, out of the 3 things I mentioned just now, the only interesting thing here is the success criteria. The acceptance criteria is the most important and interesting part here, right? Because something like build me a leveling system, right? If I write that, that is not a success criteria. That is a wish, that is a task that I want it done, right? There's nothing in there for the agent to check it against itself. So it builds something reasonable. You know, they would just decide that, oh, okay, that's probably fine. And it gives you something at maybe 70-80% done, which is the worst possible outcome, because now you have to go and find the missing 20% yourself. And you don't actually know where it is until someone gives you a bug report. What I write now looks more like the test pass, the XP thresholds trigger correctly at the boundary, and the strict logic still behaves. Every one of those is just true or false. There's no judgment left in anywhere else. So it works outside of code too, because we have these thing called computational thinking challenges in my platform, Sigmo.dev, under foundational competencies, and writing them by hand is actually very slow. So when I start writing these challenges for my students, writing them by hand is actually extremely slow, but each one has hard tests attached to it. Exactly 1 correct answer for each question. The reference solution actually runs. It sits in a difficulty band we wanted instead of being secretly trivial. It teaches the specific concept it's supposed to. None of that is taste. All of it is checkable, so it just loops. It generates, it tests itself, it bins the failures, and it goes on again and again and again. And I just review the batch of questions and answers that the loop created for me. At the end of the entire loop, so we have like hundreds of challenges, I gave it the success criteria for each question and the answers criteria for it, and I just review the entire batch at the end of the creation instead of sitting through it one by one. Now, based on how that criteria works, you get different kinds of loops. Anthropic's team wrote these up in an engineering post, and it's worth reading. And here's the version that stuck with me. The first is turn-based. That is your normal loop. You prompt, it gathers context, it takes action, it verifies what it can, and Claude itself decides whether it's done. There's no strict criteria, so it's using its own judgment, which may not be the most accurate. And a loop like this can basically just live in a skill file. So you write something like verify the front end change, or you spell out the steps, and then at the bottom, you put the looping condition. If any steps fails, fix it and rerun it from step 1, and that's it. This is a turn-based loop. Then there's another thing called the goal-based loop, which is the one I was talking about. And this is where you stop being the judge and you give it a number instead. Not make the site faster, but for example, say achieve a lighthouse score of 90 and above, right? The stop criteria is the goal hitting or not. And you run it with this thing called the /goal, right, in your Claude code. And this is the one that I use the most in Sigmo. One warning though is that for you to put a cap on the number of attempts, because if your condition for some reason is poorly written and nothing stopped, it will happily keep grinding at that forever until you feel it in the build. The next one is this thing called the time-based loop, which is triggered on an interval or a set time. For example, check my PRs every 5 minutes, handle new comments, fix failing CIs, and I've got one that runs overnight on Sigmo.dev, checking errors and fixing what it can before I'm awake. 2 commands here, and the difference matters. /loop runs on your own machine, so when the laptop is off, the loop is off. /schedule pushes it to the cloud, and it keeps running whether you're there or not. It's like an agent. It's basically an AI agent. And then proactive, which is the furthest end of it, which I don't really use that much because it is the way it works is that a ticket lands in your system and the agent picks it up and solves it, and then you find it out only afterwards, which is completely done by an AI agent. Now, I don't use it because sometimes they just may not have the right context to the features I need, so I'd rather a bit more involved in the product development of it. And if you look at these four together, because they're not really four features, they're four levels of trust. It's the same ladder that you would use with a new hire, right? Turn-based is your intern, basically. They do the work and they bring it back to you. Proactive is your senior person who just handles it and tells you after. And each rung up isn't more capacity, it's more unsupervised judgment, which is what basically people pay great money for, right? You pay a senior staff like a lot of money and you tell them, hey, I want to get more revenue from ads, and just one statement and they'll figure it out for you. But if you're talking to an intern, you probably have to define step by step. Okay, first you're going to run Facebook ads, then you got to do it creative, so you click this and click that, and you got to look at these numbers. You got to spell out the instructions step by step, right? With unsupervised judgment, it basically means that there will be more mistakes that can be made without you watching, and you basically get to trust that the agent understands you over time, more and more over time. So the way to do it is you go up the rung one by one. You don't go straight to leaving everything to AI. You go it one by one, only after the one below it has earned it and has, met the needs that you have. All right, so that's loops. But loops didn't fix my second problem, which is that after the XP and leveling feature that I was talking about, I got more ambitious and I'm handed one agent a much bigger job, and to build the feature, to write the tests, update the docs, to check it against the design, and it started fine. And then it got progressively weirder, right? It started to forget constraints that I set at the beginning. It contradicted a decision that you made maybe 40 steps before, right? And that's not a model problem. Remember that? That is a capacity and a context window problem, right? It's holding the entire job in one context window, and past a certain load, it's like your brain, right? If you want to remember one thing, it's easy to remember, but if you want to start remembering 1,000 things, you're going to remember like maybe 50, right? There is a limit to how many you can remember, and that's the same with AIs, right? You have this thing called the context window, which is that once you pass a certain load, it stops being reliable in a way that it's actually generally hard to spot because it'll start hallucinating, right? Which is the same reason why you don't give the same person in your team, 200,000 jobs, right? With the same person, you set one goal for this staff and you give it maybe 2 or 3 tasks, and that's all they do, and that's what they focus on and improve on, right? Not because they can't do all of it, it's just that, humans, we have a limited context window too. So the fix here is that you stop using one agent, and what you do is you draw a graph or a map instead. So you say this one does this one does that, here's the order, here's what depends on what, and that map is a graph, right? And that's all a graph. So the context windows are separated, so each person or each agent can focus on one task. And if you've ever told Claude Code to spin up sub agents in parallel, basically you've already built one, right? In fact, most coding agents honestly already do it in the background on itself a lot of the time. So one, for example, you want to ask it to build something, right? Maybe one is already searching for front-end inspirations, one is implementing some back-end fixes, one is writing the test coverages, all running at once, all reporting back, multiple nodes, multiple dependencies, and that's the graph. It's not more complicated than that. So obviously with a real workflow, it can get very big, very fast with a lot of dependencies between the nodes, but the concept doesn't change. That's the high-level concept. And it doesn't have to be parallel. Implement, then verify, then advise on what to change, then fix based on that advice, one after another. It's still a graph. It's a sequential pipeline instead of a fan, but it's still a map and a graph. The bit that I found the most useful is that they nest. Any node in that graph can itself be a loop. So for example, the web research node that we were talking about just now, if you give it a success criteria for what a good front-end reference actually looks like, and now it's actually looping your graph, right? So it was never really loops versus graph to begin with. It's a loop is really just a graph with a cycle around it. If you actually want to push this a bit further, you can check out dynamic workflows with Claude Code, which is basically a script that orchestrates all those dependencies for you. So for example, a workflow that audits every route handler for missing off checks, where one agent lists every TypeScript file under routes, and then a pipeline runs each file through an off check. You can get Claude to write the workflow just by asking it, or with the trigger word ultra code, which one word only, ultra code. And it used to be called workflow before they renamed it. So if you're following an older tutorial or something, that's why it may not be working for you. And by the way, none of this is new, okay? LangChain has a library called LangGraph doing exactly what we're talking about here many years ago. It's an old library, so the concept has been around since quite a while ago, but the vocabulary only became famous in 2026. How do you decide when to use a loop and when to use a graph, right? Simple version, if it's a repeating task with a finish line, it is a loop, one agent, and a job with a real dependencies. If it's a job with real dependencies that rely on each other, I would call it a graph, right? Multiple agents. And the reason for the second one isn't because of elegance or because it's cool, right? Each agent starts clean and it does one job and enhance over a finished result instead of everything it waded through to get there. But the real thing that I took away from that wasted day was neither of those. It's that I spent 2 years getting good at describing what I wanted to build and almost spent no time getting good at describing what finished looks like, what good looks like, right? And the second one now is the whole game, which means the skill that's compounding here isn't really coding skill or design skill or anything like that anymore, right? It's being able to brief someone properly and knowing how much judgment is required by the person that's doing the work that you're willing to hand over to that person, right? That's management. It's the same job, just different hire. That's it for me, loops and graph engineering. Thanks a lot for watching. I hope you learned a thing or two from this.